So this is the review for the 6.3, 6.4 quiz that we are practicing for, because we'll take it on Friday or Thursday, depending on if you have second hour or fourth hour. So here I'll work through this answer key with you. And hopefully if you've tried it and then you just want to check your answers, you can also do that, or you can kind of go along with the video. So these are using all those properties that we just learned on 6.3 and 6.4 that we did in Zoom class, and then also you did when you hopefully went over Michigan Virtual's lessons in 6.3 and 6.4. So there was the multiplication properties and then the division ones. So this first example I have, it's using multiplication properties. We have, remember, there's three properties that we looked at, which were called products of powers property. That's where you add the exponents when the bases are the same, which is what I have here. Then there are two other types that we'll see as we go through this. So this is called products of powers property, but again, you don't need to memorize those names. You just have to know how to deal with it. So if it helps, put a little 1 on top of the first -6, because there's only one of those. There are two -6 squareds. So altogether, then we would write -6. You could write 1 plus 2 if you want to show that extra step of work, or go right to -6 cubed. At this point, we need to figure out, well, what is -6 cubed? It's the same thing as saying -6 times -6 times -6, or just use a calculator and type in parentheses, make sure your parentheses are there, and raise it to the third power. So -6 to the third power is -216. That's what I get for my answer here. All right, and if you do have questions on any of these as we're working through these, just kind of star it, write some notes down for yourself, and then you can either email me or we can meet via Zoom if needed, even today on Wednesday. All right, so on to the next one. We have this next property that we're about to use is again the same one as this last one, which was called products of powers property. That means if you see a multiplication where the bases are the same, so I see this is an x and so is this, I would then be able to add their exponents. You always only add them if you see two of the same base. So in this case, I'm going to add x cubed, the 3 there with the 6. So I have 3 plus 6 as the exponent there, and then y to the 5th, like that. And then I want to just simplify this. So x is going to now be raised to the 9th power, and then the y is just still raised to 5. You don't have to put that little multiplication dot. You can either just write them right next to each other, or like how the previous problem shows, you could write it with the multiplication. It's up to you. But the final answer does look like that. All right, and then here's one more. This is now going to combine more than one property at a time. We were first just sticking with one property. Now let's see what happens when we have more than one. So if you notice, all of these are the same base. So this is going to involve using first the same property we used for these two, which is called the products of powers property, where basically if the bases are the same, you just add the exponents. So I could do 2 to the 2 plus 5, and then we still have to keep the denominator the same for right now. And then you would say 2 to the 7th over 2 cubed. Since they're both 2 on the top and the bottom, if these were different numbers, I wouldn't be able to do anything else. But because they're both 2's, I have to then use the quotient property that's called quotients of powers property, which basically says if the same bases are there, but you're doing like a fraction or a division, you subtract the exponents. So 7 minus 3 is what I would do there. So 2 to the 7 minus 3, that would be 2 to the 4th. And then I just need to calculate it again using a calculator. If you don't want to like multiply 2 times itself 4 times, 2 to the 4th comes out to 16. And that is our answer on that one. Let's try another one. This one now is called, it's a second property we saw, which was called power of a power property when you're dealing with like multiplying like this. So we now have to multiply these exponents together. So it would be y 3 times -7, which was -21, is what I would get for that first term. Then you still have y to the 8th right next to it. And now I would do again what I did for the first three problems, which is called product of powers property, combining your y's, right? Add them up. So negative 21 plus 8. You don't have to write that step down, but again, it helps just to make sure you're not forgetting to add them up. And again, we're adding here. This one we multiplied when there was only one base there, one y that had both those exponents. We had to multiply. That's how we got negative 21. But when we are now seeing two bases to the same number or letter, we then add together their exponents. So now I'm looking at y to the negative 13th, and I'm still not done because I don't want to leave a negative like that in the exponent. I have to write this as 1 over y to the 13th. This is what we learned last week. When you work with negative exponents, you can't leave your answer that way. We saw today that we need to simplify, we saw that we need to simplify when we did our notes. Anytime you're simplifying, you can't leave negative exponents. All right, let's try a few more. This next one, letter E, is hopefully a little more straightforward. It's just dealing with division or fractions. So if you want to call that a 3 to the first power, you can. We're just going to do 3 to the 2 minus 1, which is 3 to the first power, or 3. You don't have to show much work for that, or any work if you don't want to. It is up to you. Okay, the next one, now I have a negative exponent, so I have to do one of two things. I can either reduce the fraction first, or I could flip this because that's what the negative tells me to do. So if I was to flip this, I would write 14 over 2 and now make it to the positive 2 for the exponent. So a negative number exponent just flips that fraction upside down. So the 14 came to the top, the 2 went to the bottom. Now I know 14 divided by 2 is 7. So I have 7 squared, and we know that that is 49. Or you can use your calculator to figure out what 7 squared is if you're not sure. Okay, that was using, that was the last property we saw in our notes, which is called negative power of a quotient property. Now, generally, that property did say that it should get to the top and the bottom of the fraction when you raise an exponent, but that's why I reduced first, and so it was just a 7. So you're technically then, and you made this a positive, you're then just using kind of like the power of a product property, essentially. All right, here's a couple more. So the next one says r to the 6th, s to the 9th, and then I see the denominator needs to be simplified. This is called the power of a product property, where there's a product here and it's being raised to a power. We need to make sure that power gets to both terms. So r to the 4th and s to the 4th. The numerator, or the top, stays exactly the same. And then at this point, I now have to do the same thing I did like on how letter E was, where the numbers were the same. This means the R's are the same or the S's are the same. I have to subtract the exponents. So this would be R would get 6 minus 4 for the exponent, subtract it, and the S would be 9 minus 4. And you just simplify and you're done. So 6 minus 4 is 2, and 9 minus 4 is 5. So the final answer is r squared s to the 5th. And that's how you would leave your final answer. There's no more anything in the denominator, because when I go to subtract these, I had 6 r's on the top and 4 on the bottom. That's what this means. So when you cancel out the 4 from the bottom and 4 from the top, you're left with no more on the bottom, but you have 2 left over on the top. So if you'd rather just write them all out and cancel them, you can do that. It's just more to write out. And then here's another one. This next one is similar to this, where I just have to, again, raise that power to both terms on the bottom. And then I have x to the 9th, y to the 12th, still on the top, can't do anything with that. And then we subtract again. So we have the x's subtracted, x would be 9 minus 2, and the y would be 12 minus 2. Okay, and then we're just writing out our final answer, which is x to the 7th, and the y would be 10, y to the 10th, because 10 minus 2, or 12 minus 2 is 10. All right, and then we just have these last two. The last one's definitely the longest one, like we saw on our notes when we covered those. This is going to be one that's on the test eventually. It is not on the quiz, but we want to make sure we can review it before then. So let's do this one first because this one will be on the quiz. When you start this one, you have to raise everything to the third power, cubing it. But be careful with the ones that are already there, the x to the 7th and the x to the 3rd and the y to the 5th. Each of those just gets multiplied with the new exponent. So we'll have to multiply each of the existing exponents with 3. So here's what I have. 3 cubed, x would be 7 times 3. Then the denominator would be x would be 3 times 3 for the x value. And then for y, it would be 5 times 3. So all I'm doing there is multiplying each of the exponents that were already there by 3 because this is called power of a power. And then, but I'm making sure it gets to every single term. So this is technically called quotient or positive power of a quotient property. That was like the full name of it that we saw on our notes. All right, so now, and it was in Michigan Virtual as well. Let's go ahead and simplify this. 3 cubed, if you need a calculator for that, you can use it. It's 27. 3 times 3 times 3. Then we want to look at what this new x value is. This is now x to the 21st. The denominator is x to the 9th because it's x and then 3 times 3. The y value would be 15. And we're getting close to the final answer here, but we're not quite done yet because there's two x's, one on top and one on bottom. When we're simplifying, we can't leave it that way. Instead, we have to subtract the exponents. So this is just like what we did on letter G, on letter H. We've kind of done it for a lot of these. So this is dealing with that quotient of powers property. So 27 stays where it is. The x's, I would do 21 minus 9 and keep the y still on the bottom there because there's no other y's to combine it with. And then we're just writing our final answer as 27 x, and then we're subtracting 21 and 9 to get 12. So it's x to the 12th and leaving it y to the 15th for the bottom. This would be the final answer. And on to that last one. This one is definitely the longest one. Start by squaring everything on the first parentheses and cubing everything for the second one. So this would be 3 squared. A would be 2 times 2. You're just multiplying each of the existing exponents with 2 for the first parentheses. So it'd be b to the 3 times 2. And then do the same thing for the second parentheses, but you're raising it to the third power. So 2 cubed, a cubed, and b cubed, since those didn't have any existing exponents already on them. So now we're just simplifying. So we're going to start with 9 for 3 squared. This would be a to the 4th. Then we have b to the 6th. 2 to the third power, or 2 cubed, is 8. So I'm just going to leave that there. If you want to put multiplication little dots between them, you can. Or at the end, we'll just write it all together. Then we have a cubed still and b cubed still. So the first thing I would recommend is moving the numbers, multiplying. They're all getting multiplied together, not added. This is all multiplication every step of the way. So 9 times 8 would give me 72 to go in the front there, because numbers generally are written in front just like they were here. And then we have a's. So I'm going to go ahead and underline this a and this a because we'll combine those. So we have a to the 4 plus 3. That is that first property we saw, which is called products of powers property. And then do the same thing for the b's. I'll just underline it in green here. These two, because they're both b's, we'll have b to the 6 plus 3. And then you're writing your final answer as, and actually I didn't put equal signs here, 72, a to the 7th, b to the 9th. That would be as far as we can go. Can't go any further. We've combined all of the terms. All right, so again, if you have any questions on any part of this, any specific one, we can look at it in more detail. Just send me an email or we'll work through it when I see you next.